We are presenting for EC528 Cloud Computing at Boston University, and we're the bare metal marketplace team. On my Ayush, we have Manan, Haushan, and Parker, and our advisors are Sahil and Jonathan. So today we're going to go over essentially the background, and then the project goals, and then the technical implementation, and then the demonstration, and then our conclusion. So first, we're going to go over the background. So our problem statement is essentially, there are organizations who have periodic high compute requirements. And what that means essentially is that there are universities, businesses, even graduate students who need access to computing power, but not always, and only sometimes. And in those cases, it doesn't really make sense for them to want to actually, have access to, nodes in a data center or a stack of nodes because they wouldn't actually use it that often. So they only have periodic high compute requirements. Now, on the other hand, we have tenants who actually own extra compute nodes in co-located data centers. And a data center, as written on the slide, is just a shared facility with data machines owned by multiple institutions managed offsite by a co-location provider, which essentially means you have different companies or different organizations which have access to nodes or server stacks in one data center, but they don't own all of the data center. They're just tenants. But they don't necessarily use the nodes 100% of the time, so they have extra nodes, and we have potentially an ecosystem here where we have a supply and demand. So our question is essentially, how do we really want to maximize that supply and demand? And the way we want to do that is with the bare metal marketplace. Essentially, we want to facilitate the trade of these bare metal nodes between organizations. We're going to get into that in a bit, but essentially our marketplace allows these data centers to rent out bare metal nodes and remote renters to use these nodes for any purpose they like.
So bare metal servers are basically computer servers that are single tenant physical servers, and we use this term to distinguish it from modern forms of cloud hosting and virtualization. Bare metal machines don't have an operating system or a hypervisor. And the reason why bare metal is good is because it allows for high performance computing with a highly customizable hardware resource, and these can be tuned up for maximum performance. It offers a dedicated compute environment with more control for the users, and users can control these resources and have more security and have all these features in a very cost-effective way. In our project, what we've done is basically focused on functionalizing a marketplace and building it which can host bids and offers. And this marketplace has to connect to an account service, which users can use as wallets and keep track of nodes that they're renting, nodes that they're giving out for rent. And these account services have to connect to the auction service, and which matches up the bids and offers in the system. And to do the matching of the bids and offers, we use a double-blind second price auction, which we're going to talk about more soon. And we've also given a command line interface for users to interact with the system and basically add data to it, take data from it, and see what's happening. So let's talk about what a double-blind second price auction is and how it actually matches stuff. So the auction model takes the highest bid, which is in the system, and this will win the auction. It gets a second price, a price marginally higher than the bid amount of the second most expensive bid. And then we start looking at offers. If there is an offer that is higher than the second price, but lower than the winning bid, it gets matched to the winning bid or the offer price. If there are no offers higher than the second price, most expensive offer equal to or cheaper than the second price gets matched to the winning bid for second price. This is basically the second price auction. And the double blind part of it is that bidders can't see what the offers are and the sellers can't see what the bids are. So they have to make sure that the amounts that they bid for or the amounts that they offer nodes for fulfill their requirements and not try to game the market in a way that would not be economically correct. Next section of the video, we're going to talk about the goals of our project. And so our MVP in this project was to basically implement an auction system that takes in bids and offers from users and matches them up and returns contracts. So all these things need to be done to trade bare metal machines. And we had to implement a CLI which used API calls which users can use. And users can use this command line interface for accessing the system and interacting with it. we wanted the auction engine to be robust and to be able to handle edge cases and efficiently manage the matching so that we have very less downtime and uh, resources are well used. And it should be able to handle lots of bids and offers because data centers are big and these are co-located data centers, so they have a lot of machines in them. And we have to integrate all of these services into an end-to-end system which provides works perfectly. Our stretch goals were that these services should be fault tolerant, and if one of them goes down, it should not cause interruptions. And also wanted to use auto buy features for high performance computing and temporary scaling as people are working on their projects. And another stretch goal was to have a really good user interface, which has like market analytics and dashboards of what servers are live on their control right now and how the market's just running, like a stock ticker or something. It would be really interactive. Uh, Obviously, we were not able to do that much work. These were stretch goals. So the work that we have completed is a really robust auction engine, which does account for edge cases and has to efficiently maximize the matching. And this, the auction service microservice also works, and it can support the auction engine and connect it to the account service. Make sure that the economy of our marketplace is taken care of, and people who don't have money don't bid on stuff. People who don't have machines don't make up offers, and uh, all this is implemented with a command line, and users can use this command line to interact with these services.
All right, so now we're going to get into the technical implementation of our service system. So this is an overall diagram describing our architecture. There are two services, an auction service, which handles the marketplace interactions, creating auctions, and an account service, which acts as a user's wallet and ledger for any history of trade. Operators can access and control these services through REST APIs, whereas renters and sellers use a CLI, which can interface with other API calls through specific functions over post requests with JSON handling. The auction service and account service communicate with each other, but they do so in a fault-tolerant manner so that if one goes down, the other is still usable. So just to get into a little more internals of these services, both consist of an API, internal features, and databases. The auction API has the auction engine contained in it on a separate thread, which matches bids automatically to offers. The account API verifies contracts and operates on the transfer of credits, as well as recording operations in a ledger.
Now to auction service. The auction service can get the offers and bids from users and store them in the auction DB. When the contract's made it can push it to the account service to check if it's valid. For the account DB, it stores all the bids and offers from users and contracts. We are not doing any deletions in the DB. If a bid or offer is used, the status will be set to match, and if a contract is not valid, the status will be set to cancel. The main function, the most important part of the auction service is our auction engine, and we will show how it actually works in the next slide.
Great, so let's get right into the auction engine functionality. So it's very similar to the double-blind auction that Manan talked about earlier, but essentially first we import the list of, so first what we want to do actually is look at what bid we're actually going to be choosing. We choose the bid before we look at anything else in the database. So we first import a list of all of the bids, and then we look through all the bids and select the one with the lowest expiry time. So essentially sort by expiry time and get the first one. And then we look at that and compare it to all of the other bids and create a new list of bids that have that match the requirements of the bid with the lowest expiry time. Then we have that list of bids, which essentially is they're all the same requirement. Then we compare the time slots of the lowest expiry bid with the rest of the bids. So essentially, like if the lowest expiry time bid is from 2 to 4 p.m., then we look at all bids that have at least 1 hour or any amount of time within that time frame, and that's known as our clashing bids. And so we take out all the ones that don't clash because we don't have to worry about them in comparison to the bid that does clash, in comparison to the lowest expiry time bid. Then we run our second price auction selector, and what we do is we select the highest bid of all of the bids that we have remaining, and that's the bid that we return. That's the bid that's going to get matched to an offer. And we maintain that bid's price as our high price, and then we get the second highest bid, and we add 1 cent to that, or 1 credit to that, or 0.01 credits to that, and that becomes our second price. Now, what we want to do is we want to look at the offers and then generate our contracts. So the first thing we do is import the list of all the offers from the database. Then we eliminate any offer that's more expensive than our high price. Because if someone's wanting to get a certain amount of money and someone's not willing to spend as much money, then there we can't combine that offer and that bid. Then we look at all of the offers which have offer time that again clash with the rental time. Now it doesn't need to be exact. It doesn't need to cover all of the rental time, and it doesn't need to cover all of the the bid doesn't need to cover all the rental time of the offer, because we splice the bids and offers depending on how much they cover each other. So then we match it with the most expensive one that comes under higher price for the offer. So we essentially take the most expensive offer now out of the list. And if the most expensive one is less than second price, they were expecting to get less than the price of the second highest bid, then we match it for the second price. Then the person who bid is paying less than they expected, and the person who got the offer is getting more than they expected, so it's a win-win. However, if the most expensive one comes above the second price, then we match it for high price. So essentially the bidder is paying the exact amount that they were expecting to pay and they said they wanted to pay, and the offer is paying is getting either more or equal to what they expected to get. Then we send those selected bid and the matched offer to the contract creator. Now, in the command line interface, we have a seller and we have a buyer. Now, it's the same interface, but depending on there's different functionality for whether or not you're a seller or a buyer. So essentially, we have 6 total functions in the CLI. So first we have add offer and get offers, obviously, for the seller. And then we have add bid and get bids for the buyer. Now, these are the 2 different users that we expect to be using our interface. And get balance and get contracts are going to be essentially the same function for both seller and buyer. We want to get the contracts that they're a part of. And again, as it says at the bottom, they're designed based on arguments in a scriptable manner. Now, I'm going to give it off to Parker, and he's going to do the demo.
I'm going to walk you through the user experience using Bare Metal Marketplace. So, we're using Postman here as our admin console. By making requests to the server, we can act as admin to fetch private data as well as update server status. So, we can check the server and show that there are no bids, no offers, and no contracts currently on the server. So for this demonstration, we're going to be using 2 projects. Projects are the users of Bare Metal Marketplace, where they have a wallet in our account service with a specified number of credits. So we're going to be using 2 projects, Project A and Project B, which can be identified by these tags, where A is a series of A's and B is dead beef. Project A wallet has 1,000 credits in the account service, and Project B has no credits. So first we're going to use Project A's command line interface with their own config for their project ID authentication. So Project A is going to add a bid, and they're looking for a computer with 4 gigabytes of memory, 8 cores on May 7th. And they're willing to pay 20 credits for it. We're also going to add 2 offers from Project A. We're adding offers where the architecture is x86 64-bit, we have 4 gigabytes of memory, 1 physical processor. One of these offers has 8 cores, and the other has 32 cores. And then these are both listed for the same date, and the higher core count one is going to be listed for a higher price. So these have been listed in the marketplace. Now we can show our bids, offers, contracts, and balance from the CLI. So here are our bid, or this is our bid. We can also see our offers. and here are both of our offers. We can see that we have no contracts currently. We're the only person in the marketplace. And we can get our current balance from the account service. Okay, on to Project B. Project B is going to add 2 bids on May 6th for different parts of the day. So they're adding one bid with 4 gigabytes of memory requested and another. They're paying different amounts for different time slots throughout the day. But we have to note that Product B can't afford this given they have no money in their wallet. So these bids have been sent to the marketplace. We are also going to offer a computer for Product B. It's 4 gigabytes memory, x86 with 8 cores on the 7th to the 8th. So this bid matches up perfectly with what Product A wants. And it's being offered for 10 credits, which is very cheap. Now we can show the bids, offers, contracts, and balance of Project B. So there are 2 bids, our offers, our contracts, which don't exist yet, and our balance. Note that although there was a contract that matched up, the matching engine runs automatically every 15 minutes. However, the admin can force a request to start the engine at any given time. So now that the engine has been run, we can see the updated bids, offers, contracts, and balance of both of these users. So first for Project A, we'll look at our bids and see that one of the bids was matched. We can also look at offers and see that none of their offers has been taken. You can see that they have a contract and its ID and the cost per hour. And their balance following the transaction. We can do the same thing for account service or for account B. We'll see that their bids were both cancelled as they didn't have the money in their wallet to afford these when these were matched in the engine. We can also see that their offer was matched. And thus they have a contract, which is the same contract as Project A's, and we can see their updated balance. Wow, they have money in the wallet.
Now we're going to conclude the presentation with the following parts. Here's some major parts that got us blocked. The auction engine has a lot of edge cases, and going through all of them took us a lot of time. We had some conflict on how to design the service at first, so that took us some time. Also, the supporting technology availability is not that good, though, and also for the most major thing, the virus kept us home, and it took us some time to adapt to this working solution. During in this semester, we learned a lot working on this project. We learned agile, test-driven development. We also learned what's bare metal and the ecosystem of microservices, and also a lot of technologies like Flask, SQL Academy, and CLI. We have done a lot this semester. There's still a lot of things we can work on, like adding a local provider and renter service to make the communication with users much easier, and also implementing a user-friendly UI and connecting our marketplace to the multi-tenant Rungnec is also a good thing to do. We can also add like auto-buy systems and also security and authentication to our system.
Thank you so much. And special thanks to Sahil and Jonathan for advising us throughout this project. And thank you to Professor Krieger for being an amazing mentor and professor as well, and helping us learn more about cloud computing.